Hello, I am Lochanna Sengottaiyan from 4Amber. Today I'm going to talk about man-made satellites. First of all, what is satellite? A satellite is a moon, planet or machine that orbits a planet or star. For example, Earth is a satellite because it orbits the sun. Likewise, the moon is a satellite too because it orbits the Earth. These are called natural satellite. While the other type of satellite is man-made satellite, which refers to a machine that is launched into space and moves around Earth or another body in space. History of early satellite. The Sputnik 1 spacecraft was the first artificial satellite successfully placed in orbit around the Earth and was launched on October 4, 1957. Currently, the largest artificial satellite is the International Space Station ISS, that is a modular space station. ISS is a multinational collaborative project involving 5 participating space agencies, which are United States, Russia, Japan, Europe, and Canada. In terms of countries with the most satellites, the USA significantly leads the way with 859 satellites, China is second with 250 and Russia third with 146. Malaysia have launched its very own 6 satellites, which are Miasat 1, Miasat 2, Miasat 3, Miasat 3A, Tiongxat and Razaksat, which were used for several functions such as communication and Earth imaging. The International Space Station is a habitable artificial satellite that has been placed in a low Earth orbit. It completes 15.7 orbits per day and is maintained at an orbital altitude of between 330 km and 410 km. Now there are nearly 6,000 satellites orbiting the Earth, but only 40% are operating. Moving on to the types of artificial and man-made satellite. Firstly, we have navigation satellites. The GPS, Global Positioning System, is made up of 24 satellites that orbit at an altitude of 20,000 km above the surface of the Earth. The difference in time for signals received from 4 satellites is used to calculate the exact location of a GPS receiver on Earth. Next, communication satellites. These are used for television, phone or internet transmissions. For example, the Optus D1 satellite is in a geostationary orbit above the equator and has a coverage footprint to provide signals to all of Australia and New Zealand. Next, weather satellites. These are used to image clouds and measure temperature and rainfall. Both geostationary and low Earth orbits are used to depending on the type of weather satellite. Weather satellites are used to help with more accurate weather forecasting. Other than that, Earth observation satellites. These are used to photograph and image the Earth. Low Earth orbits are mainly used so that a more detailed image can be produced. Next, astronomical satellites. These are used to monitor and image space. A satellite such as the Hubble Space Telescope orbits at an altitude of 600 km and provides very sharp images of stars and distant galaxies. Space telescopes include Spitzer and Chandra. Next, we will move on to the advantages and disadvantages of satellite communication. First and foremost, the advantages are through satellite transmission, coverage over geographical area is quite large, mainly for populated areas. Moreover, it has a high bandwidth and users are able to control the system. Also, wireless and mobile communication applications can be easily established by satellite communication. Next, it is used in a wide variety of applications such as global mobile communication, business networks, long-distance telephone transmission, weather forecasting, radio TV signal broadcasting, and gathering intelligence in military. Other than that, service from one single provider is easy to obtain and uniform service is available for everyone. There are also a few disadvantages of satellite communication. These are the following. Design, development, investment, and insurance of satellite requires higher costs. Next, the propagation delay of a satellite can cause an echo over telephone connections. Other than that, satellites are not easy to repair and maintain. Also, some circumstances like weather or sunspots affect the satellite signal and can cause interference and make proper operation of the satellite very difficult. Lastly, it requires to be monitored and controlled on regular periods so that it remains in the orbit. There are two types of artificial satellite. One is a geostationary satellite and the other is a non-geostationary. Geostationary satellite is an Earth orbiting satellite, which is a type of geosynchronous satellite. It has an orbital period of 24 hours or 1 day. A geostationary orbit is a circular orbit located above the surface of Earth with zero inclination to the equatorial plane. While satellites that are not in this orbit are known as non-geostationary satellites. The satellites almost always orbit closer to the Earth than GSO satellites. NGSO satellites have a few types of satellite orbit too, such as low Earth orbit, medium Earth orbit, and high Earth orbit. This is the model of my satellite that is orbiting the Earth. Newton's universal law of gravitation. According to this law, every object in the universe attracts every object, which is known as the gravitational attraction, is directly proportional to the product of their masses and inversely proportional to the square of the distance between the center. Gravitational forces are present between the satellites and Earth by the formula shown. Satellites that are orbiting the Earth experience gravitational acceleration by the formula shown. Centripetal force and acceleration. These satellites are pulled by centripetal force by the Earth in circular motion by the formula as shown. Centripetal acceleration. When satellites receive the optimum linear speed while moving in a circular motion, this acceleration is present and acts towards the center. The formula is shown. Moreover, centripetal force is necessary to keep satellite in its orbit, because if there is no centripetal force acting on the satellite, then the satellite will travel with uniform motion in a straight line or stays at rest. Kepler's law. This law can be related to the satellite as well because satellite revolves around the Earth, which is similar to the Earth revolves around the Sun. So the principles which are applied to Earth and its movement around the Sun are also applicable to satellite and its movement around the Earth. Kepler's first law. This law is also known as the law of ellipses. This law states that part of followed by the satellite around its primary, which is the Earth, will be an ellipse. This ellipse has two focal points, F1 and F2, as shown in the figure. Center of mass of the Earth will always be present in one of the two foci of the ellipse. Next, Kepler's second law. Kepler's second law states that for equal intervals of time, the area covered by satellite will always be the same with respect to center of mass of the Earth. This can be understood by taking a look at the following figure. Kepler's third law. Kepler's third law states that the square of the period is directly proportional to the cube of the orbital's radius. This law can be written as t square directly proportional to r cube, where t is the orbital period and r is the average radius of the orbit.